Hi, good afternoon. This is Mark Moss. We're here to do some training today. We got a 1 hour segment on some more stuff on the love fryers and the filter quicks. Yesterday we had part one of it. We just kind of went over the theory and stuff. Today what we're going to do is we're going to talk about the ATO system, the MIB, and the OIB. Get a little bit more detailed on those. We have some things that's come up, some repetitious calls that we go on, stuff that we get here a lot or questioned on, and we're just going to go ahead and cover those. This on here last time, I didn't think we were going to be able to cover it in an hour. If it does go a little bit over, anybody that wants to stick on, I'll go ahead and go to its completion because I don't want to cut it up. But and then after that, if anybody's got any questions that wants to stay on, please do go ahead and stick around, and we'll be here for a little bit after. I mean, I'll be here until everybody's got their questions answered. The other thing is my email address here. Some of you guys may have taken some classes in the last couple of weeks that we've been doing like this, and I give my email. If you got questions during this, we want to go ahead and make sure everybody stays muted so I can get through it and save the questions till the end. Otherwise, we'll get sidetracked, and an hour is not very much time. But go ahead and email questions to me, and that's fine. I'll be in all week. Next week, I think I'm going to be out, but if I get an email, I look at those. I get them on my phone, so it's no big deal. I check them every day, even if I'm not working. And the other thing, okay, we have, I think, 6 1-hour training things that we have put together already. And then Roger Coley, who's in the room with me here, our tech writer, he's going to do UHC touch screens. We need some more suggestions, okay? And I do have some, but at this point, I'd like to have some feedback, say, hey, I'd like to see this. We may be doing these longer than what I expected, because usually, I mean, some of you guys have probably been to classes I've done where the level 2 classes, I come to the service companies and stuff. And I don't know for sure, but, the speculation and conversations I've been having, we don't know when that's going to return. So we want to keep up with the training. So we may have to do some other stuff. Right now, we're just having a PowerPoint, if we got to incorporate more videos. Some of the ones that I've done does have videos in it, but, we're looking for some feedback now. If there's stuff that you've done and you find that it was very helpful, please let us know. This came together pretty quick. We had this time off, and, we heard from service companies about, they had time off or some slow times and wanted to get some training done. So this came about pretty quick, but now it's time to slow down and go ahead and get something a little bit more permanent. So any suggestions you have, I was just talking to Roger before we started this one, and any suggestions you have, please go ahead and get those to us. We want to start working on that. All right, next thing, for anybody that's already done one of these courses, this right here is just our hold harmless clause. All this says here, and take a second to read it while I'm talking here, but all this says here is whenever you take this course, that does not authorize you to be a representative of Frymaster. You're not a warranty agent. You're not an authorized company. There's a lot of legal issues that go in with that, and this here does not address that. So just go ahead, and it's a 1-hour course where a lot of good information, but this does not make you a certified Frymaster technician. Okay, any licensing or anything like that you need, you're going to have to get that on your own. So, all right, that's just the legal thing. All right, next, what we're going to do is we're going to talk about 3 different systems in the love fryers and the filter quick. Hopefully, you guys went through the course yesterday and went through that, and I just talked about the theory and stuff. This is just going to go a little bit deeper. The 3 things that I think that we get questioned on the most, and when I say we, our tech support, I always poll those guys and ask them what kind of calls they're getting, and also who's the one that's calling in asking the questions. Is it end users, is it technicians, or whatever? And these are some of the things that they deal with a lot, okay, and some of the ones that has confusion. The ATO system, as simple as it is, I couldn't believe the first time I did this one today, how much time I spent on that, because we've had so many issues with that over time. And actually, it wasn't because the system itself doesn't work good. There's nothing to go wrong in it. It's just that this system here is so misdiagnosed. All right, so I want to go ahead and make sure that everybody's clear on how it works, see how simple it works, and see how something very simple, things that will wear out, or if we don't, we're not cleaning things properly or whatever, how it will affect this system and make it look like the system's not working. And then we start to change parts. Some of the components and stuff in the Love fryers and the Filter Quick, because we added so much stuff to an existing fryer. We have this jib here, a 5-gallon bucket of oil. We had to find room for that. There's just a lot of stuff in here, especially on a gas fryer. Sometimes it's hard to access things, the temperature probes. There should be no reason why we would ever misdiagnose an ATO probe. They work exactly the same, okay, as a temperature probe does on the fryer. The only issue with that, okay, is the fact they're a little bit harder to get to. And I say a little bit, they're a lot harder to get to. So to get back there to do a resistance check on them, which we'll talk about that, is a little bit difficult. So sometimes, we start to, well, last time it was this, or it can only be this or that, and you start changing parts. Once we start changing ATO boards and then a probe, possibly a pump or whatever, we've had issues before, and there's one that just sticks out in my mind that was $5,700 for a top-off issue, okay? And it turned out to be, we had a hole in an orifice that was too small, all right? And we'll talk about that a little bit later. But so, but anyway, that's why I chose to go ahead and go over the top-off system. The MIB board, or the MIB system, I guess you could call it. If you don't know how to use this, I mean, I don't know how you could work on a Love fryer and not know how to use this when it comes to any of the filtering stuff. Otherwise, you'd have to navigate through the computer to get to the filter and go through that whole step-by-step process. This board here, in which we'll get into that a lot deeper later, but that board here allows you to do all that manually. So just like before we had these automatic filtering fryers, when you could reach in there and you can open a drain valve and you can reach in there and you can turn on the or open a return valve and turn the pump and motor on. Okay, we can do the same thing now electronically by using this board. Okay, I'm going to say it now. I'll repeat it again later. When you're using that board, you're overriding all safeties. Always make sure you know what's about to happen before you start using that board. Okay, but we're going to go through all that stuff, and we're going to talk about how we can do some troubleshooting using that board. The next thing that we're going to talk about is the oil is back sensor. Okay, and what that is it's a sensor that's installed in gas fryers, Love fryers. And what it does is, if that sensor does not sense oil around it, it will not allow the fryer to heat. It won't call for heat. And if for whatever reason it does call for heat, it has a backup safety where it'll make the fryer lock out like it would, going to help ignition failure or heat failure. It'll make it lock out if the first safety doesn't work. It's a double safety on there. This right here some people get a little bit confused on it. Last class, I figured we'd have some people hanging back that would have questions on it, but I guess we went ahead and pretty much nailed it and covered it. It's very simple, but it will cause problems. It'll cause the fryer not to heat. Okay, it'll cause the fryer, to not come on, and it really doesn't give you any warning. So it's very important that we know how this operates. But those are the three topics that we're going to cover today. So with that, let's go ahead and get started here. All right, the top-off system. All right, this is the ATO probe. Okay, this is at the very top of the fry pot. On an electric fryer, you'd actually see the fill line, which is right at the edge of this little socket here. That socket is there, okay, to allow oil to go in there, okay? But the line is right there, so whenever it comes up there, that oil gets into there, it gets sensed, and then the oil stops. That's the top-off system. All right, we'll get into that a lot deeper, but the top-off system is going to be activated anytime the fryer is up to set temperature. If we haven't got to set temperature yet, we don't want the fryer to be topping off, because how this works is we compare the temperature or resistance, because they work on by setting certain resistance at different temperatures, but we compare the temperature between the ATO probe and the temperature probe. That's why it has to be up to set temp. Once the fryer reaches set temp, the ATO system engages. It stays engaged all the time. Anytime the fryer is on up to temp, it's going to be engaged unless you're filtering, okay, you're disposing oil, or you're cooking. If you're cooking, disposing oil, or filtering, the ATO system is not going to work. During filtering, you drain the oil. Obviously, there's not going to be oil on that probe. We don't want the ATO system to start adding oil. There is one other time that the ATO system is not going to be engaged, and that's if you have the MIB board in the manual mode. If it's in the manual mode, it shuts the ATO system off, okay? So when you turn the fryer on, and once the fryer gets up to set temp, the ATO system engages, all right? And it's going to stay engaged except during filtering, disposal, or during cook cycles. And that's real important because there's some confusion comes in there, and there's some things that you can misdiagnose not knowing that, all right? So anyway, how the ATO system works. We have the ATO probe at the very top, or at the highest level that the oil should be, all right? That probe is there, and again, it is comparing the temperature of this probe to this probe. Anytime that this probe is 60 degrees lower than the temperature probe, in this case here, this is an electric fryer, the temperature probe is on the element. That gas fryer that I showed you right here, the probe is right here. Anytime this probe is 60 degrees lower than this probe, then it realizes that the oil must have dropped down, because what heats these probes up is the oil. So if the oil is not there, it's not going to heat it. It drops below 60 degrees. That's when the ATO system is going to kick in. The ATO system is going to open the return valve, okay, the same valve that opens up that allows the oil to come back whenever you're filtering. And I'll show you that here in a second. That valve is going to open up, and the ATO pump is going to come on. The ATO pump is an 11-gallon per hour pump. It's very gradual. We don't want a lot of cold oil gushing into this fryer because it's going to make the fryer go into low temp. You know, certain chains like McDonald's, their fryers, when it goes into low temp, it starts an alarm and, you know, it goes off, and they don't want to hear that. Low temp means food could possibly not be cooked properly. So we don't want the a lot of oil to come in at a time. It's just going to be a very gradual amount that comes in. Okay, we don't fill the fry pots by using the ATO system. It's just to gradually top off, to add a little bit of oil into the pot occasionally whenever the oil goes down, whether it's because we're cooking product and some of the oil leaves with it, or if we filter and you know, when the crumbs and stuff comes out, if you got a brand new filter pad, the first time you filter, it's going to soak up the oil to saturate that filter pad. Well, all that oil that comes out of the pot, it's going to be a little bit lower. That's what the top-off system is for. The oil is going to continue to top off until this probe is within 55 degrees of the temperature probe. So whenever this probe just raises or rises 5 degrees, when it comes up 5 degrees, because it starts at 60. So when it's within 55 degrees, so if this is at, do the math, 295, and this is set at 350, and it is at 350, it's going to shut off because it knows the only way that this probe was able to heat up is because we got oil around it. Okay, that's how the ATO system works. If though, well, let's just mention, whenever we have oil and we drain it down, whether it's a Love Fryer, Filter Quick, or whatever, but whenever we drain the oil down, okay, we're going to have what we call the bathtub ring around the top where the oil level, or at the top of the oil. Okay, it's just a debris that floats up there and it just sticks. This is at the top of the oil level. Okay, so that debris and stuff can get inside of here. And you guys have probably, that work on these, have probably seen this before, where this here just fills up with debris. That debris has to come out of there. Okay, we have to keep that clean. The whole idea behind this, and the reason why we have a socket here that can fill up the debris, is because when the oil comes up to this line, and I'm going to go ahead and go back to this one, when it comes up to this line, the oil first goes in that socket and it surrounds that probe. Okay, that just makes the response quicker. There's more surface whenever that oil can go inside there. Whenever it shuts off, that oil level is right on that line right there. All right. So, and that's why if we had debris in here where that oil would be coming up and it doesn't go inside there, it's going to pass that. Okay, eventually it's going to get up to temperature, but it's going to slow the response down, which means that we're going to top off too much. Okay, is that a service call? We have had many service calls on that very thing right there. Now, the one thing about the ATO system is just like anything else, after it's been out a while, we have better understanding on it, and we know some of the simple things that can happen that would cause these things. All right, but when this first came out, or even still now, we get questioned on this all the time. We still have people to go out or that are new to using these fryers that don't need to know to clean those probes out. Where this right here is just going to cause it to overfill. Well, and it's not going to. I've never seen one. And on rare occasions, we probably had a couple, but you very seldom ever see it like overflow a fryer. But what's going to happen is just going to be over the limit. The one drawback here is whenever we came up with these fry pots, the whole idea behind, or the fryers, the whole idea behind them is we have less oil in the fry pot. So that way we expose less oil to the heat, to the light, to moisture and things like that. That just helps save oil. That's the whole concept behind the love fryer, which we talked about that yesterday. All right. So whenever we have issues like that, okay, where the oil comes up, or whenever now that we have a system in here that monitors that oil level and keeps it right on there, we're starting to find that some of the products that people have cooked in the past, they relied on the fact that they would overfill their pots, okay, and they actually put too much oil in them. And like I had mentioned the last time that, the earlier today when I went over this, there's a couple of chains out there that, by their procedure, the fryers don't have enough oil in them, and they know that they have to put a little bit in. That's another thing that comes up. Then it's misleading because people think these fry pots are smaller, and it's not. It's just now we have a system that monitors, that oil and keeps it at the right amount. Now, it doesn't take oil away, okay, but it will keep it at the right spot. And we tell people it's like you're not, don't add oil in there because this here is there to do that. Now, when you're filling the pots using bulk oil or whatever, that's a different system. We don't fill the pots completely using ATO, okay, because that would take the whole jug of oil. This is just there to gradually fill the pots up, all right? So whenever this probe senses a 60-degree drop in temperature, okay, compared to the temperature probe, that's when the ATO system engages, okay? And then once it raises 5 degrees or is within 55 degrees of the temperature probe, that's when it stops. Yeah, that's how the ATO system works in a nutshell. All right, some of the things that I've found that's been a little bit misleading. Well, one, let's go back up just one. On the system, when it first comes on, okay, we have the pump will come on for 1 minute, okay, and again, what it's trying to do is it's trying to get that oil level to get to that probe, okay. If it comes on for 1 minute. If we do not see the rise in temperature on that probe, it's going to stop. It sits there for a minute, and then it's going to come back on for another minute, okay? If after that minute, it still doesn't reach that probe, it's going to shut off again, regroup, and then it's going to come on, and it's going to run. Used to be on a split pot, it was 4 minutes. On a full pot, it was 6 minutes. That may have changed. We had a lot of software changes over time. That seems like an awful long time to have that thing run. It may have dropped. Subtle changes like that, they don't necessarily tell anybody because you're not going to notice it. Just keep in mind that it comes on, tries to satisfy that probe, then it goes off. It then comes back on again, tries to satisfy that probe, and then goes off, and then it'll run for an extended amount of time to get all the oil out of that jug. Okay, at that time, okay, if it doesn't satisfy that probe, it's going to go ahead on these controllers here, the 3000 controllers for a filter quick. It's going to say that the top off reservoir is empty. It's some wording like that, and then it's going to indicate though that the reservoir is empty. You have to go over and check it. When you go over and check the jib, okay, when you grab that jib and pick it up, hopefully you're going to find an empty jib. Okay, that's what you're hoping for, because that just means that we used up all the oil. All right, if you go over and you find that that jib is full, okay, then we have a problem. Okay, most of the time the problems are very simple. You see the hose right here that goes down into that jug? There's not as much room on most of the fryers as what this shows here. All right, because we had the shelf that we installed on here that would come down and it would keep that jug off the floor a little bit before we had these metal boxes made. And we kept it up off the floor to keep the cardboard box off of the floor, you know, if there was water on there when they clean the floors and stuff. All right. So it'd be up a little bit. So this thing here was a lot closer to the drain than what it looks here. This hose sometimes would just get kinked, and that's all it was. I mean, that's happened. I don't know how many times I've installed fryers, and the only problem I had was that hose was just kinked. All right, you just reinstall it in there. It's best to go ahead and have the this facing back. It just means that, you know, then it's on the other side of that, and that hose doesn't have to go underneath that drain. But usually it's going to be something simple like that. Sometimes that hose, people put that foil when they break the seal on the jug. That foil will fall down here, and that gets pulled up in that little metal weight that's in there that keeps the hose at the bottom of the jug. But simple things like that is normally what it is. It's most of the time it's nothing severe. All right, that's what I say. You know, just by having, you know, something clogged in that line is, you know, resulting in changing out ATO boards, ATO probes, pumps. I mean, all kinds of things. But anyway, we'll talk about that a little bit more. But like I said, most of the times on the ATO system, it's something very simple. Okay, we want to look at those simple things way before we start changing major components. All right. This right here, again, this here's a electric fry pot where we have the ATO probe here. Okay, that's the AIF probe, but the temperature probe on an electric fryer is going to be on the element. All right, and that sits down into the vat. On the filter quick fryers, okay, the ones, not the Love fryers that McDonald's has, but on the filter quick, we can check the temperature, and I'll show you that in another slide, but I want to show it here too. But we can check the temperature of this probe, the ATO probe, the AIF probe, or the temperature probe. All right. On the controllers, any controller that we've ever made, our computers, if we press the temperature button, it's going to tell you that the actual temperature of the oil. Okay, if we press and hold the temperature button on the controller with the controller off, all right, on a filter quick, it's going to give us the temperature of the ATO and the AIF. That's good information, considering if you got all three probes in the same oil, they should all be very close in temperature. If you got one that's way off, but you look and it's physically in the same oil, even though it may be a little bit warmer in certain regions, this should be pretty uniform. Okay, we shouldn't be too far out of whack, because 5 degrees is the trigger whenever we're the top off system. Once it sees 5 degrees, so we got to make sure that these are pretty uniform, or that oil is pretty uniform. Okay, and when we check these, we need to make sure that we're definitely within the plus or minus 5 degrees. All right. Again, just make sure that these here stay cleaned out. Okay, otherwise that oil, when it comes up, it doesn't go in there and surrounds that, and it just slows the response down. And then that oil is just going to keep getting higher. All right, here's the temperature probes that we use on there. The resistance value of these probes are exactly the same as they are in a temperature probe. If you go online, if you don't have a tech reference manual, if you go online, you can download it. Okay, and that's the manual that we use to teach our level 2 classes, our field training and stuff. If you go on there, in the back of the book, there is a resistance chart. Okay, that chart starts off at 32 degrees, which is at 1,000 ohms. Okay, again, just like our temperature probes, every degree it goes up 2 ohms. So if you're at 33 degrees, it's going to be 1,002 ohms, and it's going to do that accordingly. There is a couple of spots where it goes up more than 2, or it goes up 1, and that's just to keep that chart linear. But the rule of thumb is it goes up 2 ohms for every degree. You can look on that chart with the resistance value and it'll tell you what temperature it should be. They troubleshoot exactly the same. Those boards, just like our controllers, have a range that it recognizes the resistance. It starts at 1,000 ohms, and it goes up to, I believe it's 1,950. I always just say 1,000 to 2,000 ohms. But if it falls out of that range, that's when you're going to get your ATO probe error, or it could be an AIF probe error too. But since we're talking about the ATO system, that's where you get that error. All right. The only thing that it can be, okay, is we don't have the right resistance going back, or the board, in this case, the ATO board, is just not processing that information properly. It would be an easy thing to troubleshoot. Again, physically, it's just a little bit hard to access a place to go ahead and take the the resistance reading on these. Some fryers are a little bit easier because that plug is in the back, and then there's a harness that goes to the ATO. But either way, I mean, if you get a probe error, it just means that it's not communicating. We're out of that resistance range that that component uses, whether it's the controller, an AIF board, or an ATO board. Okay. But again, one more time, the resistance is all the same on all those probes. Usually that's indicated by the red and white wires. All right, this right here is that what I was telling you about on the filter quick when it came out in 2014. We already had the love fryers out for 5 years, and it was suggested that we have a way of checking the ATO temperature and the AIF temperature, and it just helps in troubleshooting. All right. So what they did is they wrote the software accordingly. So if you press and hold this with this saying off on both sides, with it saying off, if you press and hold that temperature button for 3 seconds, it's going to give you the ATO temperature and it's going to give you the AIF temperature. And then whenever the fryer's on, if you press the temperature button, it will give you the set temperature. They're in the same oil, they should all be the same temperature. The Love fryer didn't have that. I guarantee you they are not going to go back and change the software to put that in there. For one, and I probably should have mentioned this earlier, but these fryers here, okay, they came out in 2009. They have these M3000 controllers on it. We no longer make them for domestic use. I don't know if we sell them overseas or not. Sometimes some countries, they hang on to stuff a little bit longer, but we no longer make these for domestic use. If you buy a fryer now, you're either going to get, if you buy a Frymaster at McDonald's, you're either going to get a electric touchscreen fryer or a gas touchscreen fryer. It's going to have the same, everything we're talking about here, how the top off and stuff works is the same. All right, but it no longer has these controllers on it. They are now touchscreens. All right, so to go back now for something that's basically discontinued, they're not going to do it. But it is a nice feature to have on this one here. It does help out with troubleshooting. This right here is the elbow that I was, or the valve that I was talking about earlier. Yesterday, and also when we were in filtering, we talked about this elbow here because on the gas fryers that have that trough where all the debris settles down to the bottom, whenever we filter, then it gets flushed out. If we don't filter when we're supposed to, when the top off engages, this valve opens up and it'll actually pull some of that debris back. Okay, it can. All right, or the debris just gets clogged up in here because we let so much of it pile up. All right, and like I mentioned before, I've heard people say, well, that's just a bad design. It's not a bad design. Those fryers work better than the other ones because we have all that debris concentrated to where we can flush it out the most efficiently. All right, whereas if you got an electric fryer, okay, or if we have tube fryers that also have basically a flat bottom here. We have to use bigger pumps and to fan that oil out to get the same job done. On the gas fryers, all of that stuff is down here in this trough, not the cold zone, but in this trough. And then when that valve opens up and the pump comes on, we can flush all that out. Okay, the drawback is if they don't filter when they're supposed to, then all that debris is there and that's when this can happen. But this picture here, I'm just showing this to show that we use the same valve in the top off as we do on the filtering. The pump that we use for the top off is an 11 gallon per hour pump. Okay, it's 24 volts. It could be AC or DC. All right, and we use that pump, okay, just to go ahead and pull oil out of that jib and put it into the fry pot in a very slow rate. We don't want a whole lot of oil going in there at one time. One thing that this pump has built into it is a 45 PSI pressure switch, which means if this pump deadheads for whatever reason, normally because of a clog or something, all right, once we get to 45 PSI, that pressure switch is going to open, and even if we are putting voltage to this pump, that pump is not going to run, okay? So which means our top-off system is not going to work. You go back, you check for voltage, you're getting 24 volts to the pump's not coming on, automatically we assume we got a bad pump. We changed a lot of these pumps out, okay? Well, because of the fact that, we're changing so many out, we need to get them back and we need to have somebody look at them, get them back to the company that makes them if we got an issue with them. Well, by the time we would get them back, the pumps worked when they got here. What would happen is anytime that we had a clog and this pump comes on and we built up that 45 psi, the pressure switch would open up. Once you pull these tabs up and pull out these orifices, well, we just release the pressure. If we was to put voltage back to it then, all right, the pump would come on. So it would be fixed. The thing of it is, though, when we pulled these orifices out, it's probably because we were pulling them out to put the new pump that was ordered, because we got voltage to the pump didn't come on, so we ordered a pump. We changed dozens, I mean, probably more than dozens of pumps for that reason. One of the biggest reasons that we had when we originally made these fryers, the orifice size that was spec'd out was that size there. I don't know exactly what size that is, but it's too small. All right. What had happened is once the weathers would change and it start to get colder out, this new zero trans fat oil that we have, it gets thick. I mean, it is liquid shortening, but it gets thick. And when it would get too thick to go through that orifice, all right, it would be clogged. The pump would build up 45 psi, all right, and then it would shut off. So we would change pumps. We changed ATO boards, we changed ATO probes. I mean, it was just like we were changing everything out. Like I said, we had one case, all right, it was in a northern state, it was in Ohio. It was $5,700 by the time we got involved in it and seen what was going on. We now drill all these out to 1/4 of an inch. So when they're in manufacturing, that's what they leave it. The reason why that we did this in the first place, like I said, the customers that we were building these for at the time, they just wanted a little bit of oil to go in at a time. They didn't want a whole lot going in because it would cause the fryers to go into low temp. And that's what they didn't want to have happen. That's why we didn't start off with this in the first place. We didn't put a bulletin out or anything like that because the spec was to do this. It was just something that people were starting to do. All right. You know, technicians would tell us, like, yeah, how we fix that? We just drill that out. All right. But anyway, once it got approved that we could do this, and then we did the 1/4 inch, that problem has pretty much gone away. But the fact on how that this tells whether or not that jib is empty, okay, stuff like this still comes up. Okay, again, if you have multiple attempts to top off that fry pot and it doesn't make it, and it could be any one of these things. All right, most of the time it is never an ATO board. The pumps last forever. But anyway, most of the times it's not one of those components. It's something very simple. Okay, and we'll talk about a couple other things. One of the calls that we hear a lot also is the fact that the fryers top off too much. All right, already you should know if you got that call. First thing you want to do, and I know I'm bouncing back kind of quick, but you know, not having equipment here and things like that, it's the best way to do it. Right now, you probably are thinking, yeah, we need to make sure that probe is clean. Good, because that is probably the #1 thing. All right, that gets jammed up with debris because all that stuff floats to the top, gets in there. All right, and then that oil will pass, instead of going into that socket, it will pass right by it because it doesn't have enough oil on the surface of that probe. So that would be one thing that you want to look at. If the call is, you know, that the fryer is filling up too much or it's topping off too much, is usually how they phrase it. Here's a couple other things that we could look at. All right. When we first started making filter systems, basically what we had was a pan, filter pan. So that pan would have a hose attached to it where there'd be a hole in the bottom of the pan, and we're going to have a pump that applies suction to that, okay, and it's going to pull that oil through whatever filter medium we decide to use, whether paper or a pad or whatever. So the oil drains down in here, the pump's going to pull it through, all right. That oil then attached with flex lines is going to go up to a manifold, or actually down to a manifold. The valves are actually down here. All right. But anyway, it's going to go to a manifold. That manifold is going to get pressurized with the oil that's just been filtered. All right. That oil is going to go to any fry pot that has an open valve. All right. So if this valve here is open, okay, that oil is going to get returned back into this pot. If this valve here is open also, that fry pot's going to get oil. If they're all three open, then all of them are going to get some oil. All right. So if we're filtering one of these fryers, and this used to happen in the past, you know, we had all different ways of linkage, or all different kinds of linkage that would attach a handle that you would actually opened, that you would put your hand on and open and close the return valves. All right. We had push-pull cables, we had rods, we had all kinds of different stuff that we would use to open these valves and turn on the pump and motor using a micro switch. Well, they would wear out over time. And when they wore out, sometimes these valves wouldn't close all the way. If they didn't close all the way, even if you were filtering this one and this valve here wasn't closed all the way, well, you were going to get a little bit of oil in here, okay? And then this one here, since it donated some of its oil over here, this one here would be lower because we put some of the oil over here. So you would know that when you would go in, if it's like, okay, I just filtered and now we ain't got no oil in here and this one here's got more, plus I seen those bubbles coming in, it's like, okay, here's where the problem is. Okay, we just got a valve that's opened up and it's not seated all the way. Most of the time it's not the valves. Most of the time it was the handle or the linkage. All right. When we started making love fryers and had automatic filtration on it, okay, that didn't change. We still had those same issues. All right. Because we had actuators on there with 100 pounds of force closing those valves. It would sometimes bend these handles up. All right. Or it would bend one of these handles to where these valves wouldn't close all the way. So we'd have oil that would drip down into the filter pan. The next fryer that called for filter, the oil that was in the pan and the oil that we drained from that pot would collectively go back into that vat, so it'd make it look like it was overfilled, all right, or it was topping off too much, when in actuality, it was just losing oil. The reason why we would never know, or we didn't know, which pot was losing the oil is because the top-off system there is keeping it filled. So you walk in and you just see one that's overfilled. It's like, we got a problem with this fryer, when actually your problem may have been back here with just a drain valve. Now, how common is it for something to get stuck in a drain valve, and then when they try to close it, it puts too much strain on it, either tears the valve up, tears the linkage up. Back when we had linear actuators, this was a real problem. But in 2012, we went to rotary, so it's not as bad. But still, people forget to put, that clean out rod gets stuck in there. Little pieces of the basket get stuck in there, and it tears those valves up. And if a drain valve leaks, it goes into a pan. The next pot, the next vat that calls for a filter is going to get all the oil in the pan and also the oil that was drained to be filtered. Okay, so then it gives the illusion that we have an issue where it's overfilling when actually it's not. And I can tell you, we have spent tens of thousands, hundreds of thousands of dollars on top of issues that really weren't top off issues. I guess technically, yeah, but because it was the valves, or whatever that was, or the linkage, not closing the valves all the way. But it was just stuff we learned in the beginning. If you go out to work on a top off system, do not start looking at the biggest issues. Look at the simplest ones first, and I bet you're going to find your problem before you actually have to start changing any parts. So, all right, but anyway, this right here, this plumbing schematic is in the tech reference manual as well. We refer to this a lot. When the guys come over and ask me questions in tech support, I pull this out a lot of times. It shows you where the check valves are. This one here actually should be over here. And it is changed now in the book, but on the slide it's not. And this isn't something I can change. It was a snapshot. So, but anyway, yeah, this is a handy thing to look at. And like I said, if you want a tech reference manual, you can download them online. It's a handy book to have. So, all right. What we're going to do now is we're going to talk about the MIB. Like I said in the beginning, if you work on love fryers or filter quicks and you don't know how to use the MIB, after today, your job is going to get a lot easier. I don't know how people work on the filter system and not know how to use this MIB. One, it just eliminates you having to navigate through the computer to get to certain filtering processes and stuff. You can just do it if you want to turn the pump on to see if you fixed your problem, whatever. You can do that using the MIB board. Also, I'm going to show you where you can do a lot of troubleshooting using this MIB board. Okay, and we're going to get to that here just shortly. All right, if you walk into a store that has a filter quick or a love fryer, if you open the far left-hand door, okay, whether it's gas or electric or whatever, if you open the far left-hand door, behind there, you're going to see this. You're going to see a piece of sheet metal, a shield, okay, or a guard or whatever you want to call it, that has a cutout. All right. Under normal circumstances, or normal operation, you should either see an A or possibly a P. All right, it's going to be an A if it's ready to ask you to filter now, and if you hit yes, and if it's ready to go ahead and automatically do all that, you're going to have an A here. Possibly, though, if they have the pan out because they're cleaning it or it's just not pushed back all the way, then there'll be a P here, okay? So it's either going to have an A or P during normal operation. The reason why it knows that the pan's not in place is because we have a magnet that's on the pan, and it's going to work with a reed switch. Okay, if that switch there does not see that magnet, okay, and again, with a magnet, it has magnetic fields at north and south. So we can't have that magnet dead on. It either has to be a little bit below it or above it. In this case here, it's going to just be below it. All right, but yeah, sometimes it takes a little tweaking of this right here to adjust it. If you get a new filter pan, sometimes you have to, adjust that a little bit to make it line up. You shouldn't if everything's built to spec. But if you got a fryer that's been in use for a while, you know how fryers start to settle out and take the shape of the floor if you got missing tiles or whatever. But most of the time, we don't have too many problems with that. So, but anyway, it's there just as a safety. The fryer knows that it's not going to have you filter if there's no pan in there, because otherwise we're going to be dumping that oil all over the floor. Okay. So again, if that pan's not in place and it doesn't sense that magnet, that's when you're going to see a P show up in the MIB board. Otherwise, it should be an A. Now, when you go in as a service tech and we take that shield off, that shield is held on with T25 Torx screws. There may be one, the latest versions has been one, but before that, I know that we had as many as 3 on there, 2 on the side and 1 on the bottom. But either way, it's a T25 Torx. That's a little bit rarer than a Phillips head screwdriver or a flathead screwdriver, because we don't want people using this that's not familiar with how it works, because whenever we're using this MIB board, we override all of the safeties. All right. Well, this MIB or the MIB board lets you drain that fryer if there's no filter pan in place. Okay. Even though there's a safety on there, when you're in the manual mode, okay, it overrides all of that. If we forget to turn the fryer off, can we drain the fryer, all right, of oil and actually dry fire it? Yes, you can. Now, there's a safety that will eventually kick in, but if you was to drain that oil, you can drain that oil with it heating, okay? Whenever you're using the MIB board, you override all the safeties, okay? That's why we want to make sure that that cover always stays on there, because we don't necessarily want end users to use that. We can't tell them not to. It's their fryer, okay? But we don't want them to use it, routinely. I mean, there's been times before where there's been issues with the filter, and we've had people show customers how to filter using this. You can do that, but that's not the intent. That's not what we want to have happen. All right. Whenever we uncover this board and take that cover off, we're going to have 5 buttons down here. We're going to have the Vat Selector, okay, which this one MIB board can operate up to 6 different fryers. All right, so we have the Vat Selector 1 through 6. We have the button that puts it into manual mode. Okay, this never has an M up here. Okay, it's just when it's in the manual mode, this light is going to come on, and then you will have a number up here. Okay, so if you put it in the manual mode, the first thing that'll come up there is a 1. If it's a split pot, it'll say 1L or 1R. Okay, if it's a full pot, it's going to say 1R, and then so on and so on, 2L, 2R, 3L, 3R. If it's a full pot, it's always going to be operated from the right-hand side. But you just press this button to operate the one that you want, okay? So we just go ahead and push this button until we get to the number fryer that we want to deal with. Then this right here, you press that button. Whatever number fryer is up here, when you press this button, that fryer, the oil will drain, okay? Or the drain valve will open, I guess would be more correct. All right, this here, whenever you press this button, okay, the return valve will open. Once the return valve opens and it knows that it's open, and I'm going to tell you how it knows that it's open here in a second, but once that return valve is open, okay, and is indicating that it's open, if you press and hold that button again, not press and release, but press and hold, after about 10 seconds, there's a little delay in there, the filter pump will come on. All right. As long as you hold that button in, the filter pump will continue to run. If you let go, it shuts off. It's a dead man switch. Okay. because yeah, well, we want to make sure that somebody's there watching. We don't want to just have it on and you can walk away. All right, that's those buttons here. This right here is the reset button. Yesterday when we talked about the daisy chain, the controller, the MIB board, the AIF, and the ATO, that's all in one big daisy chain. If you have an issue with any of those components and there is an error, okay, of course the controller is going to tell you that error. But this here, this MIB board, because it controls a lot of the operations of that, it supplies the voltage to all the AIFs. It has to communicate. This is the heart of that whole system. This also holds errors in there until you press and hold this for about 30 seconds to clear that. There has been several times over the years that we've had these fryers out there, all right, where somebody will go out and they'll actually fix a fryer and repair it, and they're clear the errors out of the controller, but they still have an error locked in here. And after about 30 minutes or so, that error is going to come back. Even though the problem's been fixed, it hasn't been cleared out of here. All right, so anytime you change one of those components, we need to do a master reset, okay, and clear out everything by using the reset button, but also go in there and do this, because we don't want to get down the road just to find out that we had an error locked in here, and then you end up having to come back just to do that. All right, but that's the reset. Let's talk now about how this thing operates. So we go in and we get the VAT number that we want, okay? So we're on the number 3 VAT. So we go there, it's in the manual mode, we're on the number 3 VAT. I press this button, okay, and then that valve is going to start to open. Anytime that a valve is closed or an actuator is in the closed position, okay, the light will be off. When it's traveling, okay, or when that valve is going from closed to open and you hear it running, that light will be flashing. Once it gets to all the way to the open position, that light will stay on steady, okay? How it knows what position it's in is by a resistor or a Hall effects or something with inside the actuators, that the resistance value changes depending on the position of the actuator. So when it's in the closed position, it recognizes that resistance as the closed position. This light will be off, indicating that. All right, when it's all the way open, the resistance value that it sends back, okay, it knows that it's in the open position, so it's going to indicate that by the light staying on, okay? When it's in travel, it's all over the place, and that resistance is moving, and it's not stable, then it's going to flash because it doesn't know what's going on, all right? It can just assume that the actuator is traveling. That's why it's not locked into any one resistance, okay? If you have an actuator that's bad, or if you have an AIF board that is bad, that is not giving a signal back to this MIB that has a stable resistance on it, guess what? This light will be flashing. If you go in and you pull the cover off, okay, and say it's, you know, still in the automatic mode, but if you pull that cover off and you have a light flashing here, we got a problem, okay? The problem may be that something got stuck in one of the valves and can't close all the way, and it's not in the fully closed position. If it's not in the fully closed or fully open position, it's going to flash. And it could be something that's simple. You know, we clear the valve out and then go ahead and close it all the way. Once it's in the all the way closed position, then it should work just fine. That happens. I mean, you know, clogged valves is not that uncommon. All right? One thing on this reset, or when you come out of the manual mode, it puts everything in the closed position. So if you're changing an actuator, close the valve, hit the reset, plug in the actuator that you're changing, okay? And then when you install it on that closed valve, the actuator knows that it's closed because it was in the closed position because we hit this reset. As long as the valve is physically closed, then it's going to start off in the closed. Then when you go to open it, it knows to open. All right. Okay, this right here. So we take off the cover. There's still an A right here. Let's go back to one that does show an A. We have this light here flashing. Okay, that means that there is a drain valve in this 4-bank fryer, okay, that we have a problem with. How do we know which one? Just by seeing this light flash. Well, one, we may be getting an error on the controller on the fryer, but maybe not. But we can go into the manual mode, use this locator. If we go into the manual mode and there's a number 1 here and this light went off, Okay, our problem's not with the number 1 fryer. We press the locator and we go to the number 2 pot. If that light is off, then we know we don't have a problem there. We go to the number 3 pot, and now this light is flashing. Our problem's on the number 3 vat on the drain valve. Okay, which more likely it's going to be the actuator. So how we check the actuator? We just swap this actuator for this actuator. It's on the same AIF board, or you may have a spare actuator that you just carry with you. All right. I mean, if you do, you can just plug that in. If the problem stays with the actuator, if we swap these two around and now our problem goes here, meaning it stayed with the actuator, we got a bad actuator. There's no more troubleshooting involved. If it stays with the position here, okay, meaning now we put that actuator over here and we don't have a problem. The problem's with the AIF board that it hooks to. I have had just as many no, I hadn't. It's been more actually, but I've had several times where you get that indicator, okay, and it's an AIF board. I'm not saying that we have bad AIF, but I just know it sticks out of my mind where I've changed an AIF board because of that reason. It wasn't an actuator, it was a board. Sometimes if you get an AIF error, okay, on a fryer, always disconnect the actuators too, okay? Because sometimes a bad component on a board will weigh it down. That's kind of more what we talked about yesterday. But anyway, just, those actuators sometimes go bad. They work hard, all right? If they go bad and they're causing a short or something like that, it's going to show up on either here or it's going to give an error on that AIF board, okay? And it could just be an actuator. But that's how you can troubleshoot an actuator. It's simple. Yeah, I hate to say it, you don't even need a meter. Because anybody who's ever taken a class before, I always say is like the difference between a tech and a maintenance guy is we have meters and we know how to use them. All right, but in this case here, this is the best way to do it. Those new connectors and stuff on these components are hard to get readings on. But this is a very effective way of troubleshooting. In using this MIB board, hopefully you guys that never used it before that's worked on these, hopefully you see the value in this. If you got to do a boil out, fill them all up with water, heat it up, let it, boil a little bit, shut them off. Then you can come down here and just use this to drain them out. All right. There's just 1,000,001 different uses on this board here. If you need to just test to see if the motor comes on now. There's a video that Roger and myself did late last year, that tells you how to clear a pump out. We had one that was locked up. We cleared it out. It works great. Still working good to this day. Thing of it is, we went to the MIB board to test it. And I don't want to go through the computer and get locked into one of those long filter processes. Okay. Same way with boiling out. I mean, a boil out, that's an hour-long process. You can go in and put water in there if you're just cleaning the pots. Put water in there and then drain it using this board. Just always remember, you override the safeties using this. And one rule on using this board is if you're getting ready to push one of these buttons, make sure you know what's about to happen and make sure that you're prepared for it. All right. Another thing that I'm going to bring up, I'm going to go back to here. Well, here will be good. If you have one of these lines off, okay, and this is an automatic filtering fryer with automatic top off. If you have one of these lines off, cleaning out that elbow or whatever, if you got that valve off of here, make sure the fryer is off, okay? Not just, well, nobody's there, they're not going to use it, because don't forget, automatic top off opens up this valve. These valves are down here at the bottom. Whatever oil is coming out of there is going to go in that manifold, and if you have that manifold breached or opened up, all right, that oil is going to come back out on you. All right, do not work on these fryers on here or take these lines off with the fryers on. Even if they're not using it, if the automatic top off kicks in, you're going to get oil coming back on you. All right, so yeah, if you ask, can we work on it? Absolutely not. All right, I think we might make this here. We're going to talk about the OIB real quick, though. The MIB has its own transformer. It supplies the voltage to the AIFs. On an electric fryer, it's behind the computer. The 24-volt DC relay for the filter system. It's always been AC before, but now it's DC because we rectify that voltage for the actuators. That relay is going to be behind the far left computer on an electric fryer. On a gas fryer, it's down in the transformer box with all the other transformers. All right, now we're going to talk about the OIB, okay? Hopefully this will go quick. We got 5 minutes, but I want to get through it. I don't want to have to cut this up. All right, here's the OIB sensor, okay? And that screws into the fry pot. It looks like a high limit, and that's where it is. We have to have oil surrounding this before this fryer is going to be allowed to heat. This is the heat transfer area right here, okay? So as long as we have oil up to this level, that is covered. We can safely have the fryer come on. That's the whole idea behind this. The components with the OIB, there's where that sensor is, and actually it's a heater. There's where that is. This is what we call the egg. The electronics is inside of here. This is a 7-second time delay relay board, okay? We need to power up this egg with 120 volts on a Love fryer because McDonald's does not use basket lift. We use the basket lift relays, which that's what these are for you guys that hadn't taken the other courses we've done in the last couple of weeks. These relays here are going to be used to give 120 volts to this egg, which is going to supply the voltage to that heater. And I'll tell you how that works in a second. If you're a non-McDonald's, some of our customers that buy these fryers do use basket lifts. So instead of using these relays, we had to put a separate OIB relay in there. This is a 12-volt DC coil. So when you turn the computer on, 12 volts DC goes to this relay. It energizes and sends 120 volts to our egg, which I was going to show you that egg, to the egg right here. All right. So now that we know where all the components are behind the computer here, okay, and this here is located in the front of the fryer. Now that we have all this, and again, this is only on a gas fryer. It's not on electric because we have another safety on electric fryers. It's built into the computer, but it won't work on a gas fryer. All right. So now that we know where all those components are, let's talk about this system. We have the part that goes into the fry pot, which is just a heater. This is a submersible heater that is set at one temperature. That temperature, I don't know. It's over 500 degrees, 500 or better. You know, because we used to say 550. You're like, no, it's only 500. It really don't matter. It's more than 350 or 375, which is our highest set temp that we want anybody to use the fryers at. But it is a heater. For the sake of discussion, we're going to say 550. It is a heater that is set at 550 degrees. This thermocouple here is going to send a signal back, you know, just like, you know, a Garland grill or a Merco cabinet or whatever. It's going to send a signal back here, okay, voltage, a small amount of voltage that is going to be produced because it's heated up by this heater. Once this sends a signal back to the egg with the controls in there and the little circuit board in there, and it sends back a signal that this knows that it's at 550 degrees. Well, guess what? We're at 550, that's set temp. We're going to shut the heater off, which means we're going to cut the 120 volts to this heater. All right? Just like anything you set a temperature on. All right? So it's just a heater that it's set at one set temperature, 550. So once this heater goes off, or once that thermocouple sends a signal back here to shut the heater off, the 120 volt goes away. All right? It's going to go away until the thermocouple sends another signal back saying, we just dropped in temperature. We're below the 550. We need to come back on. That happens in about 3 seconds, okay? So that takes about 3 seconds. So once it's off for 3 seconds, it's going to go ahead and cool down, and it's going to do that fairly quickly, 3 seconds, and then it's going to come back on. So it'll actually pulse on and off until it gets, once again, put in something, you know, liquid or whatever, that's going to go ahead and keep that temperature below that set temp. The reason why we have that 7-second time delay relay board is we want to make sure that we have voltage, okay, that we are going to tap off of here in parallel, that we have voltage on that relay for at least 7 seconds, okay, because then we know, okay, there must be oil in the pot, okay, because we have voltage coming here for at least 7 seconds. That heater stayed on for 7 seconds. It's not coming back, or it's going to stay on. If this was just immediate and there was no time delay in there, this thing would cycle on and off every time this cycled on and off. So that's why we have to have that time delay in here. That, as long as we have oil around here, this little 40-watt heater cannot heat up 30 pounds of shortening to 550 degrees. This will always be below 550. This will always have 120 volts, which means this will always have 120 volts. So the contacts on this relay right here and right here are going to be closed. These contacts is in series with the 24 volts AC to the gas valve. If we don't have that voltage to the gas valve, it's not going to come on when it calls for heat, okay, because there's no gas. That's what's going to make the fryer go into heat failure, or it's the same thing as ignition failure help, but on these fryers here, it says heat failure. Just like an open drain switch or an open high limit, it's in series with the high limit. It won't get the voltage down to the gas valve, the fryer won't come on. Before that happens, though, we have to have a signal from the AIF board, which we talked about that yesterday. The AIF board, we have to have a signal to the computer or the controller. If it doesn't get that signal, it never calls for heat. So this here should never matter. All right, this is just a safety net. This is just a backup because we don't want to have issues where the heat will come on without enough oil in there. But that's how this works. Just think of this is just a heater that we tap off in parallel to energize a relay. All right, and that's it. That's how it works. I don't know if somebody here engineered this or where this idea came from. It works perfect for us. All right. Granted, there's float switches and things like that. Float switches and fryers don't work all that great. So this is a lot more reliable. Do these things ever go bad? Yeah, there's a heater in here. Elements go bad, and that's what that is. It's like a 40-watt light bulb. It's eventually going to burn out. All right, but as far as a big widespread problem, there's been some change, but hasn't been an issue. But knowing how this works is very important because you can have a fryer not calling for heat, and it could be this right here. So we're 2 minutes over, so that's not too bad. I thought we were going to go a lot longer than that, but anyway, that's all I got. Tomorrow, huh? Oh, yeah. On the next slide here, there is one more thing. This right here, those sensors, they need to be cleaned regularly. This right here, that's not that much. I mean, sometimes these things, because this is a heater and that new oil clings to anything hot, these things here get really built up with this carbon, and it slows the response down. Either way, either it'll make it not heat or it can make it heat when it shouldn't. So we just got to just make sure that these stay cleaned. Okay, that used to be a lot bigger problem than what it is now. And it's probably because people now, these been out there a lot longer, people know to clean those. But anyway, that's it for now.